and get to know our ideas and the vision for our EMS. Because at Enapter, we believe that the future of energy is both hardware and digital. There's a clear path towards decentralization in the energy field, and the share of renewables is increasing. So energy producers are no longer these traditional power plants that are far, far away from the energy consumer. Actually, today's electricity producers are of all shapes and sizes. Some of them are at an individual scale, as seen in the form of prosumers, while others are at a larger scale, for example, with microgrids. And microgrids will become an integral part of our electricity landscape. They provide reliable autonomy as well as clean energy. But in order for microgrids to unlock their full potential from an ecological, economic, and a social standpoint, they need to be smart, because microgrids have the potential to enable a higher utilization of green electricity. And in order to achieve this, we must establish a smart energy management strategy. And so this is where an effective energy management system comes in handy, because an EMS will turn your measurement into data, data into knowledge, and knowledge into action. So today, we want to show you just a glimpse of how we can do this, how our Enapter EMS does this in a live and practical demo. And you can drop your questions in the chat during the presentation, and we will address them at the end. So without further ado, it's my pleasure to invite Nikolai.
Good. Vaitia, thank you for a nice introduction. Yeah, I'm totally agree with you. It's very nice to see a lot of new names around. So this is this would be very interesting demo. So let me share my screen. So I prepared a few slides. Just a second.
Super.
Okay, so our plan for today. So I would like to show you the few steps, actually the 5 steps, which will help us to integrate the real Confavent air handling unit, which has a rotary heat exchanger using an Enapter energy management toolkit. So mainly these type of air handling units, they are used for the private households. By finishing this demo, first of all, you will understand what an Enapter blueprint is. You will also understand how to monitor and control the air handling unit using the cloud dashboards and mobile application using any network around the world. With mobile application, which you can download from the Google Play Market or Apple App Store. Also, you will know how to use the performance data for the future automation and improving the energy balance of the household and the microgrid. So before we'll start, let's have a look on the device we will be working today. So on the screen, you can see the air handling unit, which main role is to take the fresh outside air and bring it to the home. Also, it take the exhaust air from the house and take it out to the street. However, with just a ventilation approach, we may run into some efficiency problems. For example, in the cold regions, in the winter time, the cold intake air, the removal, so intake of the cold street air and removal of the heated house air can dramatically decrease the increase the energy bill. So for this case, our air handling unit has a rotary heat exchanger, which is actually preheat the street air with a removed heat from the exhausted home air. The integration of the air handling unit will be done using an Enapter Energy Management System toolkit, which is a modular hardware and software solution which helps our partners to build their own energy management systems to keep energy balance by planning energy production and consumption for any kind of projects, either households or it can be industrial projects. So let's start. Step number 1. On this step, we need to identify the integration interface for our unit. In general, this kind of device is controlled with a wall-mounted human-to-machine interface. So you can see this on the left. So this is C4 HMI. But the disadvantage of this interface is that it does not have remote control and monitoring. For this purpose, the manufacturer provides the Ping2 control unit, which allows to control the system using the web management interface, Modbus TCP, or Modbus RTU, but only in the local area network. For our integration, we will use Modbus RTU interface. The step number 2, we need to select the right universal communication module, which will be suitable to our integration interface. Universal communication modules are very compact, DIN-rail mountable, low-power wireless devices. In our portfolio, we have UCMs for all kinds of protocols, such as Modbus, CAN bus, HTTP, analog and digital inputs, analog output, and relays. So many of them. Each of such UCM have microcontroller with a firmware which can be updated over the air. Also, each of these UCM have a unique QR code and PIN code to make setup easy and safe using the mobile phone camera and application from the app stores. The last but very important feature, especially for today, because we will be using it, it's a Lua interpreter. It enables simple customization and support for third-party devices. In our case, this is our air handling unit. So for our integration, we choose the ENP RS485 module, and you can see it on the screen. It provides RS485 interface and will be connected with our Ping2 module. And on the other hand, it can be connected to the cloud using the wireless connection. Okay, so the step number 3 is actually to make the cable connections and make the connection to the cloud of our UCM. On the screen, you can see the high-level diagram for our setup. For RS485 interface, it's rather simple because the RS485 network consists of 2 cables which are marked A and B on both sides of the devices. So we just connect J3A wire to A terminal block on ENP RS485 and B cable to B connection on the module. On the other hand, the Ping2 control module is connected to the existing C4 human-to-machine interface, to the ventilation unit, and also we connected to the network switch with IP address 192.168.123.6. We will be using the connection to the web interface of the Ping2 module to control the system, because actually it's located 20 kilometers away from me at the moment. So this is this slide shows how the actual physical setup looks like. So here you can see our ENP RS485, and here you can see our Ping2 module hanging on the cables and connected to the switch. So here is a router which has given us an internet connection. During this demo, I will skip the step with the connection of the UCM to the cloud. But on our YouTube channel, you can find the video which explains this process. It's done in a very easy way. You just need a mobile app. You need to scan the QR code on the UCM, enter the Wi-Fi SSID and the password, and then when the setup will be finished. Right now, our UCM is already connected, and we are ready for the next step. So the next step for us is to identify the monitoring and control metrics we would like to use with our air handling unit. because our air handling unit already connected to the TCP/IP network, and we have the web interface. We will connect to it, and using the web browser, we will check which abilities our air handling unit has. Just a second, I will share the screen. So here is our air handling unit web interface. So here we can see the PNID of this device. So the top vent line shows us exhaust line from the house through the filter, through the rotary heat exchanger, through the fan, which is running on 55%, through the damper out to the street. The bottom vent line shows us the intake air, which is coming through the damper, filter, then the rotary heat exchanger, the fan, which is running at 65%. Then this is an electric preheater, the chiller, and inside the house. Also, we can see here the temperatures. The black is the current temperature of the intake air, and in the blue, we can see the set point for the temperature. Also, we can see that right now the air handling unit is running in the mode 2, and we have the first control function, which is on and off. So let's turn the system off. If we will press this button, when we press this button, we can see that the fans are stopped. The operation mode now turns to off. The rotary heat exchanger stopped. And just in a few seconds, the dampers will be also closed. We will keep the system off until we will do the final integration, and we will turn it back on using the mobile application and the mobile dashboard. So let's briefly check what kind of modes the air handling unit has. Okay, so we have 3 modes. The mode number 1 sets the flow rates to 30% of intake and exhaust fans. This is usually away mode when there is no one at home. The mode number 2 sets the supply flow to 65% and extract flow for 55%. So this is a general mode when people are in a house. And mode number 3, it's a forced ventilation because both of the fans are running 100%. Also, we have a possibility to set the temperature set point and change the season. So the season is responsible for setting up either the electric preheater or cooling unit. Okay, so this is the data which we can get from the system. The last very important setting we need to check is a connectivity. Because we are using the RS485 interface, we need to check the connection settings because they need to be the same on the both sides. So here we need to write down that the Modbus ID slave is 20, and the RS485 interface settings are speed is 19,200. We have 8 data bits. The parity is even, and 1 stop bit. So we need to save this data because we will later use it. So let me summarize which monitoring and control functions we would like to integrate. For monitoring, we will read the mode. We will take the intake and the exhaust fan speeds. We will read the temperature. And for the control, we will make start and stop commands, and we also will make temperature set point. Okay. After checking the documentation for the air handling unit, I prepared this Modbus register table, which has all registers, Modbus registers, which we will use in our integration. All of them are marked in bold, and they are just a 6 register. All of these registers are holding. This means they can be used for both for the read and the write functions. However, the manufacturer specifically mentioned which can be used for the read-only operations and which can be used for read and write at the same time. Let's have a look on few of them. So let's have a look at the register number 999. So this register is responsible for starting and stopping the ventilation unit. So if we write 0 into this register over the Modbus, the unit will stop. If we write 1, the air ventilation unit will start. In the register 1200, there is a temperature set point, and this is a read-write register. But what is important, that the temperature there is stored multiplied by 10. So, for example, if we would like to set 25.5 Celsius, in this case, we need to set 255 into this register. For all other registers, the principles are the same, so there is no need to explain all of them. Let's go to the next step. The next step is the last one. So this is the step where we are starting to implement our blueprint. The information about the blueprints, as Vaitia already mentioned, will be available after the demo on our Enapter Developer Center page. The page address is developers@enapter.com. The Developer Center offers tools and documentations to help our partners to integrate Enapter solutions with their products. But first, let me explain what Enapter Blueprint is. The Enapter Blueprint is a bundle of files which are written in YAML and Lua languages. These files are used to declare possibilities of integrated device. In our case, this is air handling unit. The main part of the blueprint is a UCM Lua script. And it handles the low-level integration of the device with the UCM. This script handles Modbus communication as well as device-specific logic. For our example, it can be conversion of the float point temperature into integer number using the multiplier. The second part is cloud device data model. Here, we will use YAML to describe the data to store and show in the cloud, as well as the commands which will be available for the user. Also, it handles the alerts, which can be sent over the push notifications, but this will be outside of today's demo. You can check this later. We will prepare some nice videos later. The blueprint can be handled in different ways. The first way is when you prepare the blueprint on your computer and you upload it using the command line tools for any operation system like macOS, Windows, Linux. The second way is to use the web IDE. And today I will show you this way because from my point of view, this is the most easiest and simple way to do integration and prototyping the same way as we do it today. Okay, so before we will start, let's overview the Modbus register table again, but this time it is extended because I've prepared some mappings in between the registers and the functions in our blueprint and the variables. For example, our Modbus register 999 will be mapped to the functions start and stop, which role is to set either 1 or 2 or 1 or 0 into the holding register 999. For example, in the register 1200 with the temperature set point will be mapped with a variable temperature set point in our telemetry. Okay, now we are completely packed with information, and this is the time for the demo. Let me share my screen with a web browser and with my mobile application. On the left, you can see the the browser, which is connected to the cloud, and on the right I will connect my mobile phone to the streaming applications. Good. Okay. First of all, let's, because we skipped the step with setting up the UCM, let's first of all check that it's online. So our UCM is called UCM 3FCA, so you can see it here. So if we will go into this UCM, we can see that the dashboard is pretty boring. Yeah, so we can see that the device is online. We have one command which is reboot. We have a standard icon, and there is not much data, but it will change soon. So the first thing we need to do, we need to create the blueprint. For this purpose, I will go to the blueprint section of the cloud and will click the create blueprint button. Then I need to make the name for this blueprint. Let's name it Hannover Messe demo. And the product which we are integrating is ENP RS485. And then I click the create button. Okay, so the web IDE open. So on the left, we can see list of the files of our blueprint. So there is a firmware Lua which is responsible for the low-level integration on the UCM side, and we have a manifest YAML, which is our data model declaration. So let's start with changing the icon for our integration. So here I need to add icon property. We have a big list of different icons, but yeah. So let's try the first one, which is, for example, Enapter vent. And let's try to upload this blueprint to our device. For this purpose, we will click Upload to Device button, and we will choose our UCM from the list. So here it is. So the upload is started, and you can see that immediately the icon changed. But this icon does not represent our device. So for this purpose, we have another one. So this is an Enapter vent recuperator. And let's upload it again. Okay, nice. The icon is changed, and we can see how easily the interface is changing. So the next step for us would be to send some telemetry from the air handling unit to our cloud. As I already mentioned before, we need to write down the Lua script, which will do that. Because we are using the Modbus RTU, we need to establish serial connection. For this purpose, we will use the RS485 library and the init functions of it. So I will type RS485, and here you can see that the web IDE is auto-completing my input. So it helps me with the next steps. So I will choose the RS485. Then I press dot, and then I will choose the init function. So the init function has several settings. So the first is a baud rate, which is 9200. The data bits is 8. This is the information which we stored before. The parity is even, and the stop bits is 1. The buffer size we will use standard, so it's not needed. So here is the initialization of the interface. The one more thing we need to do, we need to declare the address library address variable where we will store the address of our Modbus device. It is 20. Yeah, so we saw this in the settings of our air handling unit. Okay, so the interface is set up. So the next thing we need to do, we need to send some telemetry. The first one we want to send is the current mode of the air handling unit. So for this purpose, we need first to read the Modbus register, which is let me check. The status, the current mode is located in the register 1100, and it's represented by the numbers. So the 0 is stop, 1 is mode 1, 2 is mode 2, and 3 is mode 3. Okay, easy. So for this purpose, we will declare the table, and we will use the Modbus library and the function which is called read holding register. So the address of our device is located in the address variable, which is declared up in our code. Then we need to put the start register. The start register is 1100, and we want to read one register. The timeout for this read will be 1 second. So here we put the number in the milliseconds. The next thing we need to do, we need to check if the read was successful and the data table has any data. So for this, we will use if statement from the Lua standard functions. So it would be if data, then because we have several possibilities for of the modes, we need to explain each of these modes. So if data is equal to 0, then we want to set the status to stop. This means that our air handling unit is stopped. The same we need to do with other modes. So if the mode is 1, then it will be mode 1. If it will be 2, it will be mode 2. And if the data 3, then it will be mode 3. Okay. So as soon as we will read and parse this data table, we will have the status located in the status variable. So we need to send this variable to the cloud, and we want to send it in the status variable. Okay. Okay, let's try to upload this blueprint to the UCM. Okay, I uploaded the blueprint, but nothing happened on the dashboard. And the reason is simple, because we did not enable the data model for the cloud. So right now our cloud does not know which data needs to be showed and which data needs to be stored. But we can check if the telemetry is already sent to the cloud. For this purpose, we open the terminal in the IDE, and we can see that our telemetry is sending the data to the cloud. So in the status variable, we have stop. This is what we did using the web interface of our air handling unit. So we stopped it, and now it's in the stopped state. So this means that everything works fine. But how we can bring this to the dashboard? For this purpose, we need to switch to the manifest YAML file, and we need to declare the telemetry properties. So I will write down here telemetry, and the one which we are sending is status. Okay, so the display name for this will be status, and the type we are sending is string. Because we have several possibilities for this, it would be enum, which we will define. So this is stop, this is a mode 1, this is a mode 2, and this is a mode 3. Okay, let's try to upload the blueprint now. Okay, I made a mistake. So here we are. As soon as I uploaded to the cloud, the interface of my mobile application changed, and I can see that the status is stop, and also it's written down on the main status bubble of the device. Okay, so this is about the telemetry, but we want to start our air handling unit. So for this purpose, we need to register the command. To register the command, we will use an Enapter library, and we will define this command in the Lua script. So we need to register command, which we will call start. The name is start, and it will be the second argument is an anonymous function. Okay. So the main role of this function is to set the Modbus register 999 to 1. So for this, we will use Modbus library, and we will use the right holding function. So the address of our device is located in the address variable. The register we will be used is 999. The value is 1. This means that we start the system, and timeout we will set to 1 second again. Okay, so let's upload it to the cloud and to the UCM. But as we can see, we still don't have this command. What is the reason for that? Yeah, the reason is the same. We need to declare to the cloud which commands are available for the user and how they are named and how they look like. So for this, we will open the manifest YAML, and we will declare the command groups. Group. Okay, so the sorry, it's command groups. So the group, let's name it manage. So the display name will be manage air handling unit. Okay, and the next step is to create the command. So the command which we want to make is a start. So the display name will be start. Then we need to make the UI. We want to have the icon for this command. So let's make it power on. And we also want this command to be available for the quick access for the user. So it's mobile quick access will set to true. Yeah, the last thing I forgot to do is to assign this command to the group manage, which we created before. Let's upload it to the cloud. Okay, as you can see immediately in our quick commands menu, we've got the start command with an icon. So if I will press this command, my air handling unit will start. As you can see on the telemetry, it's immediately set to the mode 2. And also, if I will check the web interface of the ping2 module, we can see that, yeah, we can see it in a few minutes, because it's not minutes, but seconds, that the system is started. Yeah, you see that the damper opened. So this means that the system is ready to start the fans, and in a few seconds the the system will start. Meanwhile, you can see that while we have the system turned off, the temperature raised up to 28 degrees. We have very warm weather at the moment in the St. Petersburg. Okay, so yeah, so the heat exchanger started, the fans started as well. Okay, so let's continue with our integration. So let's make the dashboard nicer. So let's also add additional metrics. We wanted to have the temperature and also the rotation speed of the fan. So for this purpose, we will do the following. So, oops, sorry, wrong place. So the temperature is, let me have a look. The temperature, the current temperature is located in the register 1199. So we need to read 1190 register. If data, then we need to assign a telemetry temperature to data 1. Okay, and let's do the same with the intake and exhaust fans. So for this purpose, we will read the holding register 1114 and 1115, and here the registers are going one by one. So for this, we will read the register 1114, and we will read 2 of them. This means that in our table, we will have 2 items. The first will be intake fan speed, and the second will be exhaust fan speed. So okay, intake fan. Okay, so this is the second one, and let's upload it to the UCM. Okay, but nothing changed on the dashboard there, because we need to change the manifest YAML as well. So here we need to say that we have temperature. The display name will be temperature. The type is float. Intake fan. Speed type is integer, and exhaust. fan. Okay, so let's upload it. Let's see what we will have there. Okay, so, but the temperature is very strange, right? So it's says 23.4, but not 23.4, but 234. And the reason is because, as I mentioned before, it's stored multiplied by 10. So we need to divide it by 10. We will open firmware Lua. We'll find our temperature, and we will just divide it by 10 and upload it to the UCM. Here we are. So right now the temperature is shown correctly. So this is what we can see in the on the dashboard. So let's have a look how these dashboards looks are shown in the cloud, in the web interface. So I will go to the cloud.enapter.com. I will go to the list of the devices. I will check the device, and here what we can see. So here is our control group with the commands, and here we also have a dashboard button. So if we will go to the dashboard, we can see all our metrics available on the dashboard. So for example, if we will set it to automatically update every 5 seconds, it will be almost real-time visualization of what is going on with the air handling unit. And if I will, for example, set it to the mode number 3, which is to run the fans on 100%, we will see that immediately as soon as I made this change, this was registered in the cloud, and we can see that the fans are right now are rotating much faster, and the temperature will also will go down in a few seconds. So this is the way how you can visualize all the data which is coming from the energy device. You can analyze this data with the dashboards, or if it's not enough, you can export this data from the cloud using the export function and use any of the tools on your computer to understand how to make your system better, how to optimize your energy system, your energy devices, and automate the operations of them. I think that, yeah, so it's pretty much enough for the demo. If you have any questions, I would be happy to answer them. Okay, I have a question from one of the participants. So the system, the question is the following. So the system shows 28 degrees, yeah, the temperature, but the weather right now in St. Petersburg is around 15. So it's from 11 to 15. So the reason for that is very simple, because this ventilation system has a rotary heat exchanger. So this means that in-house air, which is around 21 degrees, is going through the heat exchanger, takes the heat and preheat the incoming air. So this is the reason. But 28, it was because the system was stopped and it's insulated very well. So this is the reason. So we stopped the fans, and the air was not going back and forth. So this is why it's raised up to 28 degrees.
And so in theory, you could also remote monitor and control any kinds of devices, right? Yep. So today we did a demo of this heat exchanger, but we could really go into... Any kind of energy devices.
Yeah, exactly. So for example, here I also have the dashboards for the solar inverter. So for example, we can see, let's take it for 24 hours. So yeah, so we can see that actually the sun is also coming to St. Petersburg. So right now it's so it's producing around 400 watts. The power is 400 watts. So it's charging the batteries, and yeah, the life becomes more sunny. As the same way as some of other devices, for example, there is the water meter, which is showing the amount of the water used. Yeah, so it's growing, right? So and so on. So any type of device can be easily integrated the same way.
Yeah, that's fantastic, because in microgrids, if we think back to the white paper that you wrote, there's so many different kinds of energy devices. And in order to really make it efficient, I feel like this is the way forward to really understand the whole performance.
Welcome to visit our developers, enapter.com. So Vaitia, you are right. So hardware diversity is welcome. So this is what we say about the energy devices. So our goal is to make them integrated into the seamless network, where you can easily monitor, control, and design your own functions, control functions based on your demands. So this is the idea of our toolkit, and you can check more details on this page.
And yeah, thanks for everyone who joined. As you know, at Enapter, our mission is to replace fossil fuels ASAP with green hydrogen. So we would go do this. And yeah, thanks for joining, everyone. Appreciate your time. You'll find all of our resources online, as you can see here on the website. And for now, I would say thank you for joining. You can always email us if you have any questions, and we'll see you another time.
Thanks, everyone. Thanks for joining. I hope it was interesting. Have a nice day.